we will start with the theorems of one variable. It's involved only one variable is over there, and specifically we want to learn 5 theorems. And again, a theorem is proven by using truth table. That one is one of the very easy way to implement it. If the number of inputs is only a few. In this case, we'll have only one input variable, so it's very easy to just simply use the truth table to prove that. And they can be proved using axioms or other proved theorems as well. So now we'll learn this 5.1, and we'll learn what is that theorem, okay? And also we'll learn its dual form, okay? Then we also learn what is its name, and we'll learn why is this one helpful, why should we study this, okay? So in order to tell whether it is useful or not, we'll just give some example. If you see some complicated circuit, then using the corresponding theorem, we can replace that complicated circuit into a much simpler one. So here is the theorem T1, and it is B and 1 is B. Okay, this one is B and 1 is B, and its dual form is B or 0 is B. So its names is called identity. It's the same. B and with 1 is still the same B. B or with 0 is still the same B. That's why it's identity. And why is this one helpful? So if you see the gate like this, which is the AND gate between B and 1, produce the output Y, then it simply will just replace that with or if you see B and 0, okay, or B or with 0 and produce Y, then we can simply just replace the two gates, whatever gates here, with the wire itself. It's just a wire. We do not need another gate. Well, simply Y is B anyway. Y is B anyway. That one is how is it helpful. Now the next one is the theorem T2, which is B and 0 is 0, and its dual form is B plus 1, or all 1 here is 1, and this one is called null element. Okay, then let's say if we see a gate like this, which is B and with 0, then it's gonna produce Y. Then we'll just simply replace that with 0 to Y. Y is 0 anyway. We don't have to use a gate for this. We can simplify this one by throwing a gate away. Or if you see B for this second dual form, if you see B or with 0 produce Y, again simply replace that one with Y equal to 1 by this wire. Okay, so we don't have to provide gates. Then the theorem T3, it is B and B is B itself. Okay, then its dual form is B plus B is B itself, and this one is called idempotency. Okay, this theorem is called idempotency. So if you have in your equation a B and you add the same element into it, and that's the same thing. It's not gonna do any other thing. So if you have B plus B is at B, this one is pretty helpful. This one is pretty helpful. Okay, or if you have one element just dot the same thing or AND with the same thing, it's just like not doing anything. So this one is very helpful. It's idempotency. Now what is this one for? One example over here is if you see B and B over here produce Y, or you see B or B to itself over here produce Y, then simply just replace those gates. Just simply wire B to Y to produce the output. Okay. Now this one is a fourth one, which is T4. So it's going to be negated, or the negative version of B. So it's gonna produce B itself. So if you negate B for one time, then you negate it once more time, then it's gonna bring back to itself. This one is also very helpful. Operators theorem, and this one doesn't have its dual form because it doesn't involve the and or operator. It doesn't involve 1 or 0 in there, so it doesn't have its dual form. Okay, so this one is called involution. Okay, and let's say this one you negate b for the first time, then you negate b for the second time using the not logic gate, then you produce y. Then simply you just replace this two logic gates with the wire itself, because y is b anyway. Now the next one is T5. So you're gonna have b and not b is 0. Okay? We cannot have b and not b appear at the same time, so it is gonna be false. Okay, and the next one is its dual form. Again, convert the dot into the plus and 1 into 0 or 0 into 1. So this one is b plus not b is 1, or b or not b is always true. You know, you just b or not b is always true. That one is simple. And this one is called complements. Okay, so itself or not itself, of course, is always true. This one is important one as well in simplification of our Boolean equation. And if you see b, you end with not b equal to y, it's simply replace that by y wired to 0. And if you see b, you or with not b, produce y, simply wire y to the 1, to the positive. Okay? So for this one, there is only one variables in there. And how do we prove this? It's very simple. It's fast, easy to just prove them using truth table. Okay, you provide the truth table for b and 1, then you see the truth table with b, and if they're exactly the same, then that's it. Okay, then they're the same. It's very similar. We'll do for others. Okay, if the truth table of the two sides are the same, then they are the same. Okay, they are equivalent. Okay, so next time we'll learn about the other theorems. Okay, with more variables.